In this video, we will be talking about how to graph quadratic functions. So I have drawn a function in purple, and normally where it crosses the x-axis, those are called the zeros. So over here, we have another 0. And place where it's crossing the y-axis, those are called y-intercepts. And this is not only true in quadratic functions, but it's also true in all other functions. And depending on cases, sometimes the vertex has a minimum and sometimes it has a maximum. The line that's shown in a dotted line, those are called axes of symmetry. Axes of symmetry. The reason why it's called the axis of symmetry is because when you fold the quadratic functions with respect to that line, all the values are going to match up very nicely. So it's always symmetrical, and it always has the axis of symmetry on quadratic functions. In quadratic functions where y is equal to ax squared plus bx plus c, if a is greater than 0, in other words, if a is positive, then the function is concaved up, meaning that it's going to have a shape that looks like this. So we call this as a concave up. That's a great way to remember. When a is less than 0, in other words, if a is a negative number, then it's going to have this shape. That's called concave down. When the graph is concave up, it has a minimum, as you can see, and when the graph is concave down, it has a maximum. There are different ways to write a quadratic formula, and according to it, there are a number of different ways that we can graph this. The most famous ones being the number 1 and number 3, but we'll look at all 4 cases. If y is equal to a times x minus p times x minus q, we know at value of p and q on the x-axis, those are where the zeros are going to be. And depending on whether a is positive or negative, it's going to be concaved up or concaved down. Let's assume that a is positive, so then it's concaved up. So graph will look like this. Quadratic functions comes with a line of symmetry. That line is equal to x is equal to p plus q divided by 2. For the second function, where y is equal to a times x minus h squared, when x is equal to h, that's where the zeros are going to be. And again, depending on whether a is positive or negative, it's going to be concaved up or down. Let's assume that a is positive, so it's concaved up. And since h is the only time that it's going to cross the x-axis, this we call it as it's touching the x-axis at h. Axis of symmetry, then obviously it will be at x equal to h. For the third equation, y is equal to a times x minus h squared plus k. We call this as a vertex form because at h and k, that's where the vertex is. So we have a graph, a vertex at h and k with a line of symmetry, again at h equal to x, or x is equal to h. Lastly, we have y is equal to ax squared plus bx plus c. The roots, the zeros of this equation, if a is positive, will be at x is equal to negative b minus square root of delta over 2a. for the one on the left, and then for the one on the right, we'll have negative b plus square root of delta over 2a. The line of symmetry on this function will be at the average of these two roots, the zeros, which is going to be at x equals to negative b over 2a. Let's sketch the following functions. First, we have y is equal to 2 times x plus 3 times x minus 1. So we know that our zeros are at negative 3 and positive 1. So at negative 3 and positive 1, that's where we're going to have our zeros. When x value is equal to 0, y value is 2 times 3 times negative 1, that's negative 6. So that's my y-intercept. When x is equal to 0, your y value is at negative 6. After foiling this function, we have 2x squared plus the remaining, so we know that a value is positive 2, so it must be concaved up. So we'll get a graph that looks like this. Alright, for the second function, we have negative 2 times x minus 1 times x minus 2. So this will have a 0 on 1 and 2. When x value is 0, the y value will be negative 2 times negative 1 times negative 2, which is going to be at negative 4. So at 0, it's at negative 4. And then since this has a negative 2x squared of the remaining after you FOIL, this is concaved down because the a value is less than 0. So the graph of this function will look like this. Lastly, we have y is equal to half of x plus 2. I'm missing a square in here. Alright, so we have a function y is equal to half of x plus 2 squared. Again, we're going to have the zeros at negative 2. And since this is the second case that we looked at previously, it's going to be touching the x-axis at negative 2. It's not going to cross the x-axis. We know that when x is equal to 0, we have a y value of 2. So it's going to be at 2. Also, we know that this is concaved up because it's going to have 1/2 x squared and remaining, and that 1/2 is positive, so it must be concaved up. So we're going to have a function that looks like this. Given a graph of y is equal to negative 2 x plus 1 squared plus 4, find the vertex, axis of symmetry, that's AOS, y-intercept, then sketch the graph. We already talked about the vertex form, and this is somewhat in the form of the vertex form. We have y is equal to a x minus h squared plus k. Has a vertex at h and k. Notice that k remains the same. Positive k, k. It's a negative h that makes it an h for the vertex form. So in this case, if you have a positive 1, that means your vertex must be at negative 1 and 4. So for the x-coordinate, you have to negate that answer. For the axis of symmetry, if we think about this graph, we're not sketching this, but we're briefly trying to get the idea of what this function will look like. We have a vertex at negative 4, 1, and 4, so somewhere in here. And we know that this function is concaved down because it's negative 2x squared, so it's concaved down. Axis of symmetry happens where the vertex is. So that must be x is equal to where the x value is, negative 1. Y-intercept is when x value is equal to 0. So when x is 0, you have 1 squared, that's just 1, times -2, that makes it -2 plus 4, so y is equal to 2. Now that we have all these information, we can sketch this graph a little bit more accurately. We have x and y axes. Vertex is at -1 and 4. Y-intercept at 0 and 2. And we know that this graph is concave down, so it will look like this. Let's find the vertex of a given function y is equal to 2x squared minus 8x plus 1. This is the last quadratic form that we looked at on the second slide. The axis of symmetry on this graph is at x equals to negative b over 2a. So that's negative 8, that's positive 8, over 2 times a, which is 2 times 2, 4. So the axis of symmetry must be at 2. So when the x value is 2, what is my y value? Y is equal to 2 times 2 squared minus 8 times 2 plus 1. We have 4 times 2, that's 8, minus 16 plus 1, that's -8 plus 1, so that must be -7. So vertex on this graph is at 2 and -7.